Hello everyone, welcome. It's Cheng here. In today's video, I want to show you how to draw a project network, and then I will show you how to identify the critical path. You can pause and read this problem, and I'll go ahead and start drawing. The first thing I want to do is I want to draw an activity node to use as a reference. Let me draw it here. In the activity node, we divide it into 6 parts, and we call each activity activity I, and each activity will have a duration and earliest start time, earliest finish time, latest start time, and latest finish time. Okay, so this is our activity node. We can draw it on the side to use as a reference. And then we can start working on the project network. I'll start from the first activity, activity A. Okay, and I'll draw from here. Activity A takes 9 days to finish, and the first activity, the early start time is time 0, and earliest finish time is earliest start time plus the duration of this activity. And then let's move on to activity B. Activity A is a predecessor of B, so let's draw another circle for activity B. Activity B takes 3 days to finish. The earliest start time for activity B is equal to the earliest finish time of activity A, so we copy the 9 here, and 9 plus 3 is 12. And activity B is the predecessor of activity C and D. So like this. Activity C takes 11 days to finish, and the earliest start time of activity C is day 12. So this is earliest finish time 12 plus 11 is 23. And activity D. Activity D takes 7 days to finish, and the earliest start time for activity D is day 12. The earliest finish time is day 19. And then let's move on to activity E and F. They both share the predecessor D, so there will be 2 arrows coming out of D. Activity E takes 8 days to finish. The earliest start time is day 19, so the earliest finish time is day 27. And we draw activity F. F takes 6 days. The earliest start time is day 19, and earliest finish time is day 25. Okay, and then let's move on to activity G. Activity G has 2 predecessors, C and F. So let me draw it here. G takes 21 days. And now we need to choose between day 23 and day 25. So now let me mark the number here. To find the earliest start time for activity G, we need to choose a number between day 23 or day 25. And now we are working on the forward path. In the forward path, we choose the maximum number or the earliest date because we have to make sure all the predecessors are finished before we can work on the successor. So here we choose day 25. And earliest finish time is 25 plus 21 is 46. And then activity H takes 10 days to finish. It has 3 predecessors, C, E, and F. Okay, C and F. Let me draw it here. And again, we are on the forward pass, and we need to choose between day 23, day 27, and day 25. It should be the latest date, day 27, and earliest finish time is 37. Okay, and activity I has a predecessor H. Takes 15 days to finish. The earliest start time is day 37, and this should be 52. And last one, activity J, has two predecessors, G and I. Okay. J takes 5 days to finish. And between 46 and 52, we choose the 52 because this is a later date. And the earliest finish time or the completion time of this whole project is day 57. And now we finished the forward pass. Let me write down the key points when we are working on the forward pass. In the forward pass, to begin with, we work on the first activity, and the earliest start time of the first activity is time 0. And for any of the activity, earliest finish time for any activity is equal to the earliest start time of any activity plus the duration of those activity. And moving on, when we are trying to figure out the earliest start time of a successor, and that is equal to the earliest finish time of its predecessor. But sometimes when we have multiple earliest finish time to choose from, like here when we are trying to calculate the value for the earliest start time of activity H, this one right here, we have multiple earliest finish time there. In this case, we choose the maximum between all those dates or the latest date. So that is the max. Okay, and that completes the forward pass. And now let's move on to the backward pass. So this time we are going from the last activity to the first activity, and this is called the backward pass. And we start from activity J, the last activity. The first step is we want to figure out this value, the latest finish time of activity J, and this value is equal to earliest finish time, 57, and then we just copy the value down, 57, and then we do the subtraction. Latest start time is latest finish time minus the duration, 57 minus 5 is 52. And then we copy the 52 to the latest finish time of its predecessor. 52 goes in here, and 52 goes in here. And then we do a subtraction. 37, and this is 31. And then 37 here, 27. Okay, now it's a bit complicated when we have so many arrows here. Let's start from activity C then. Activity C has two successors, G and H, and we are choosing in between those two values, day 31 or day 27. In the backward pass, we will choose the minimum number or the earliest date because we need to make sure the predecessor C is finished before we can start on G or H. if activity H can start on day 27, meaning C is finished by day 27. So the value should be 27. 27 goes in here. And then this is 27, 19. And for activity F, we are choosing in between date 31 or day 27. And again, that should be 27. 21. And here we are on latest finish time of activity D. And that is a value either 19 or 21, and the value should be 19. Okay, and 12, 9, 9, 0. Okay, that completes the backward pass. And I'm going to write down the key points when we are drawing for the backward pass. Okay, in the backward pass, we start from the latest finish time of the last activity. Latest finish time of the last activity is equal to the earliest finish time of the last activity. And this is also the completion time of this project. And then when you will use the latest finish time to calculate the latest start time. Latest start time of any activity is equal to the latest finish time of any activity minus the duration. So here we do the subtraction. And then we are going to figure out the latest finish time of the predecessors. And latest finish time of a predecessor is equal to the latest start time of its successor. However, sometimes we have multiple latest start times to choose from. For example, in activity C, there are two latest start times to choose from, which is 31 or 27. And we want to choose the minimum or the earliest, because if a successor can get started on that date, meaning the predecessors are already finished. So this is the backward pass. And next, I want to show you how to identify the critical activity and the critical path. And now we need to calculate the slack. Let me write it here. Slack is equal to the latest finish time minus the earliest finish time. It's also equal to the latest start time minus the earliest start time. And those values are always equal to each other. And now we can calculate the slack. Okay, and now we finish calculating the slack. And those activities with zero slack, those are called the critical activities. If we connect them, we will get the critical path. So next, I'm going to connect all those activities with zero slack. Okay, the critical path is A, B, D, E, H, I, J. And the critical path is also the longest path. And that completes the project network lesson. If you have any questions, please let me know. And thanks for watching. See you next time.